Hi guys, welcome you all to my channel Explore Edu to Teach.
So today we'll be learning another important concept in case of network analysis called as the source transformation. So this is another technique in order to find out the voltages across a particular element, current through a particular element and various other parameters which might be asked for you in the question. So there are other techniques like we have solved mesh analysis, nodal analysis. If you haven't watched the video, please go and watch it out. It is present in the control system playlist on my channel. So the next technique is source transformation. As I mentioned, this is another technique to find out the different parameters of a circuit, like solving a particular circuit. I hope I'm very clear with this. So let us first understand the rules that we are going to use for source transformation in order to solve a particular circuit. Once the rules are clear to us, then we can go for solving the circuits. I hope I'm very clear with this. So what is source transformation? So as the name suggests, we are going to transform the source. And what is my source going to be? A voltage source can be transformed into a current source. A current source can be transformed into a voltage source. So by these techniques or rules, we can solve the circuits and try to find out the various parameters in that particular circuit. So taking the first case or the first rule in case of source transformation, it says a voltage source with a series resistance. So if you see, a voltage source is in series with a resistance can be converted or replaced by an equivalent current source with a parallel resistance. So this entire circuitry in which I have my voltage source in series with a resistance can be converted into a current source in parallel with a resistance in which my R value will be same as this, but my I value will be given as V by R. I hope I'm very clear with this. Let's talk about the second case or the second type of technique. It says a current source with parallel resistance can be converted into a voltage source with series resistance. So if you look over here, I have a current source which is in parallel with a resistance. I can always convert it into a voltage source with a series resistance. It's just the vice versa of this. But if you look at one thing, when the voltage source was having a positive terminal above and a negative terminal below, the current source was pointing upwards. Why? Because a current source always moves out of a positive terminal. This is a convention that we take. Similarly, when the current source was pointing downward, I had to take the positive terminal downward because the current source will move out of a positive terminal. Had my positive terminal been upward and my negative terminal been downward, then it would have indicated that my current source is entering the positive source, which is not as per the convention. So to summarize it, if I have a voltage source in series with a resistance, I can convert it to a current source in parallel with a resistance and vice versa. If I have a current source in parallel with a resistance, I can convert it into a voltage source with series in resistance. However, remember that my current source direction will be always coming out of the positive terminal of my voltage source. Since the positive terminal is upward, my current direction is upward. Since my current direction was downward, the positive terminal will also be downward. I hope I'm very clear with this. These are the two basic rules of my source transformation. If you understand this, we can definitely solve the numerical which is given over here. So if you look at the numerical, what does the numerical say? By source transformation, find the current in the 3 ohm resistor, this resistor. I hope it's very clear. Now the same thing you can solve by mesh analysis also, by nodal analysis also. If you're interested, let me know in the comment section. I will give you the solution of the same problem by mesh and nodal analysis also. But give me a good response to this video. Share it to your friends, and if you're interested, please let me know in the comment section. I will do for you in the mesh and nodal analysis way also. However, for such a complicated circuit, source transformation can be a better option. So let us see how do we solve this particular question by a source transformation technique. So if you see, a voltage source is in series with a resistance. So what is its equivalent transformation? It's going to have a current source in parallel with a resistance, right? When a voltage source in series with a resistance, the equivalent transformation is current source in parallel with the resistance. So you will have a current source coming here. Current is always V by R, that is 6 by 2 is 3 amperes, and a 2 ohms is going to come over here. I hope I'm very clear. The current direction is upward because it is moving out of a positive terminal of a voltage source. Now, my 2 ohm and 6 ohms are in parallel with each other. So you have a 3 amperes current here, or 2 ohms and 6 ohms are in parallel with each other. That means the value will be 1.5 ohms. I hope that you know to find out the parallel combination equivalent resistance. Now again, a current source is in parallel with a resistance, so I can convert it to a voltage source in series with a resistance, right, from this formula. So my voltage source is going to be I into R, that is 3 into 1.5, 4.5. Resistance is going to come over here, 1.5 ohms, 2 ohms, and the rest part of circuit remains the same. Now 1.5 ohm, 2 ohms are in series, that is 1.5 plus 2 is 3.5 ohms. I hope I'm very clear till here. Again, a current voltage source is in series with a resistance, so I can convert it to a current source in parallel to the resistance. How does this value 1.28 comes? It is 4.5 divided by 3.5, and then I have a resistance of same value, that is 3.5. Now again, if you see over here, this current and this current are in parallel with each other, right? The 1.28 ampere current and the 3 ampere current are in parallel with each other. So I can straight away add the two current, that is 1.28 plus 3 amperes, it is 4.8 amperes. The 3.5 ohm resistance remains the same, the 1 ohm resistor and the 3 ohm resistor. Again, you have the 4.28 ampere plus the 3.5 ampere in parallel. So I can convert it into, or there is no need to convert as such. We can just keep the equivalent circuit as it is. If you see over here, this circuit and this circuit is the same, right? So now I need to find out the current through the 3 amperes, the 3 ohm resistor which is mentioned. Therefore, the current to the 3 ohm resistor is equal to 3.5, that is this one, upon 3.5 plus the equivalent, that is 4, into my net current, will give me 1.997 amperes. So how does this formula come? This is a current divider formula. If you have two resistance in parallel and you have a current source in parallel to them, if you want to find out the current source to 3 ampere, it's going to be 3.5, the other resistance, upon 3.5 plus 3 plus 1, that is 4, into my net current, that is going to be 1.997 amperes. So I hope I'm very clear with this. I'll give you a short summary. Source transformation is like any other technique, like your mesh analysis, nodal analysis, which is used for finding out the different parameters in a particular circuit. So source transformation gives us the rule of converting a voltage in series with a resistance to a current source in parallel with a resistance, and a current source in parallel to a resistance with a voltage source in series with a resistance. Just be very careful of the direction. The current source will always come out of the positive terminal. So accordingly, you have to give the direction. I hope I'm very clear with this. Then we have this particular circuit. Just keep on solving one after the other, and the rules which are going to be applied are only these two rules. So just keep on solving it. If you see over here, 1.28 amperes and 3 amperes are in parallel. So I can add these two current source to 4.28 amperes. Finally, I'm applying the current divider formula and I'm finding out the final answer. So this is a very simple technique. These notes are going to be available in my description box also. So please download it from there. Please share it to as many friends as you can, to your people in your college and to other study groups also, so that all can get advantage of it. Thank you so much.